Alright, here we go on section 6.3, definite integrals and antiderivatives. Here are a few derivatives, not antiderivatives, but derivatives. Just wanted to see if you could find them. Go ahead and push pause and try maybe the odds or the evens, or see how many of these you can get done. Here's your answers for each of them. If you have questions on them, you're welcome to ask me tomorrow. What we're going to do tonight is talk about properties of definite integrals and the average value of a function, which involves the integral, and the mean value theorem for definite integrals. In your book you'll find this chart, or now you have it here in your notes, just all the rules for definite integrals. Notice on number 1, the order of integration affects whether your integral is positive or negative. We tried that yesterday, from going from like 2 to 4 and then 4 to 2 or something like that, how it makes your answer negative. This is why, or here's the rule that says that's why. Number 2, if you're taking the integral from a to a, so from 3 to 3, there's 0 area under the curve, so it's equal to 0. A constant multiple, if you have a k times your function, any number times your function, you can either take your integral first or you can take your integral after you do that. Same thing is true with a negative. We have the sum and difference rule, saying that if we're adding or subtracting two functions, you can either take your integral after you add or subtract them, or you can do it before you add or subtract them. Number 5 is the additivity law. Sorry if you can hear my husband getting ice in the background. It says if you're integrating from a to b of one function and then integrating from b to c of that same function, I promise that's a pop and nothing else that he's drinking. It's the same as integrating from a to c of that function. Min and max, we can talk a little bit about that tomorrow, but you have your rule there. I think if I draw you a picture quick, you will understand what it's talking about. So if I have a function that goes like this, it's saying that the minimum area rectangle is going to be smaller than the actual area, which is going to be smaller than the maximum height times your width. So that's maybe confusing as I drew it, but I think I'll be able to explain that one pretty simply tomorrow. And then same with number 7, we can just talk about that a little bit tomorrow about domination. What it's saying is that if one function is always above another function, then the integral of that one function is always going to be more than the integral of the other function. And again, if that's not making sense, we can clear it up tomorrow. So using our rules for definite integrals, this says, in case it didn't come through very well, that we have an integral from -1 to 1 of f at x that equals 5, an integral from 1 to 4 of f at x that equals -2, and an integral from -1 to 1 of h at x that equals 7. And so we want to find the integral from 4 to 1 of f at x if it's possible. Well, using our rules of integration, we know that since the limits of integration are flip-flopped, we can just take our answer and flip-flop it. So the integral from 4 to 1 of f at x dx is just going to be equal to a positive 2. And it says that there. How about this one? Find the integral from -1 to 4 of f at x, if possible. Well, we know from -1 to 1 it's 5, and then from 1 to 4 it's -2. So since that upper limit of integration is the same as this lower limit of integration, that we could combine those together and find the integral from -1 to 4 of f at x dx just by taking 5 plus -2. So my final answer here is 3. Alright, so on this one it's asking us to find the integral from -2 to 2 of h at x. And we know from -1 to 1 is 7, but we don't know anything about -2 to 2. So it's twice as wide, but we don't know anything about the height, so just not enough information is given here. Alright, so let's move on and start talking about the average value of a function. It's also called the mean, so we're talking about just truly the average y value of the function, and we can find that average value by finding the integral from a to b of your function and then multiplying it by 1 over b minus a. So this is a formula that will come in handy, that you'll use quite a bit when you're trying to find the average value of a function. So let's try it. If we're trying to find the average value of f of x equal to 2 minus x squared on 0 to 4. So there's my formula, 1 over b minus a times the integral from a to b of f of x dx. So I have 1 over 4 minus 0 times the integral from 0 to 4 of my function 2 minus x squared dx. So I have 1/4 times my integral from 0 to 4 of 2 minus x squared dx. And you can go ahead and type that integral from 0 to 4 of 2 minus x squared on your calculator, because we don't at this point have a way of finding that. Multiply that times, and you'd get your answer of -10 over 3. So that is the average y value of this function from 0 to 4. The mean value theorem for definite integrals says that if we're taking the average value of my function, which is what this is, right? Average value, we just wrote down that formula, that somewhere my function is going to be equal to that average value, because f is continuous on the interval from a to b. So the mean value theorem for definite integrals says that the average value using your integral will be equal to your function somewhere. This is the picture of that and why. You know that the integral is the area under a curve, so if you take it times 1 over b minus a, you're getting your average value. That's going to be equal to your function at some point. Here's just our derivative of an integral. If you hadn't guessed it yet, now you can see by this problem right here that derivatives and integrals cancel each other out. So if you take the derivative of an integral, you are left with your original function. Notice a couple of particular things about this. My bottom integral is a, so it's just a number, and my top limits of integration is just x. So if it's something other than x, then it's something we would have to deal with just a little bit differently. And if your bottom number is not a number, if the bottom number is not a number, then we have to find a way to make it a number, something we will practice tomorrow. And so that's where I'm going to go ahead and stop. We will work on example problems tomorrow. Have a great night.